Hi everyone, welcome to Unit 9, Lesson 1. We're starting a new unit on Unit 9 titled Introduction to Waves. And so we'll go over a few lessons just to end our book study for over the next few weeks. So for today, we're going to look at the digital lesson for Unit 9, Lesson 1, which is titled Waves. And then I'll show you a clip from PBS Learning, and then we'll end with assigned practice time on IXL. So go ahead and look at the digital lesson from our textbook.
Welcome to the lesson, Waves. We're going to look at different types of waves and explore how waves make it possible for us to hear sounds and see light. The vocabulary words for this lesson are medium, mechanical wave, electromagnetic wave, longitudinal wave, and transverse wave. Another astronaut is floating next to him and talking. The two astronauts are able to hear each other without a radio link. Is this statement true or false? Click your answer.
True or false, an astronaut floating in space can hear sounds.
Well done. The astronauts would need to use a radio link because they wouldn't be able to hear each other in space without one. There have to be particles for sound waves to travel. In space, there are no particles. Waves are disturbances that carry energy. When you talk, you disturb the air and produce a sound wave. When you touch water, you produce a wave. Waves are often classified by the way the disturbance travels. Click each type of wave to explore this idea further. In a longitudinal wave, the disturbance vibrates parallel to the direction that the wave is moving. Think about a large spring. Pushing the coils of the spring together and then letting the coils come apart produces a longitudinal wave. When the particles in the wave push together, this is called compression. When the particles move apart, it is called rarefaction. The rarefactions and compressions occur along the same line in which the wave moves. The particles in a transverse wave move perpendicular to the direction that the wave is moving. If you tie a string to a doorknob and move the end of the string up and down, it is an example of a transverse wave. The string particles move up and down, but the wave moves forward. The top part of the wave is called the crest, and the bottom part is called the trough. Many waves transmit their energy by disturbing the matter that they move through. Matter that a wave moves through, such as air or water, is called a medium. The particles in a medium move as the wave passes. But particles in a medium don't move in the same way that the wave energy moves. Click the pictures to learn more. Plucking a string on a guitar makes the string vibrate, and this produces a sound wave that travels through the air to get to your ear. As the wave travels outward, the air particles don't travel outward with it. Instead, the particles near the guitar vibrate back and forth around their original position. The vibrating particles hit particles a little farther away. These particles then start to vibrate back and forth. As the wave travels, air particles farther and farther away from the guitar are hit and start to vibrate. In this way, the energy from the guitar string is transferred to your ear. If you have ever gone fishing, you might have noticed that the bobber at the end of your line moves up and down as a wave passes by. The bobber moves with the water particles around it. The water particles move up and down as the wave passes through, but they do not move along with the wave. Instead, They transfer the energy to other water particles along the direction the wave is traveling. Energy from the wave is transferred from place to place, but the matter in the medium simply moves up and down a little bit as the energy moves through it. Some waves, like sound waves, need a medium to travel through. Waves that need a medium to travel through are called mechanical waves. Electromagnetic waves, or EM waves, are waves that do not need a medium to travel through. Electromagnetic waves are waves caused by disturbances in electric and magnetic fields. They can travel through a vacuum. Click the pictures to see what types of waves are mechanical and what types of waves are electromagnetic. Have you ever thrown a pebble into a pond? You might have noticed how the water rippled as the rock hit the water. Water waves are mechanical waves, and the medium the energy travels through is water. Water waves are usually surface waves, which are a combination of both longitudinal and transverse waves. In an earthquake, the energy travels as mechanical waves. Rocks and other materials, like soil and water, in and on the surface of Earth, are the medium for earthquake waves. Some earthquake waves, called P waves, are longitudinal. Other earthquake waves, called S waves, are transverse. You wouldn't be able to hear the sound without mechanical waves. Sound travels from its source, like a saxophone, to your ear through the air. Air is a common medium for sound waves. Sound can also travel through other materials, like water or wood. Although the microwaves in a microwave oven can travel through air, microwaves don't need a medium to travel. Like light, radio waves, and X-rays, microwaves can travel through empty space. Energy from the sun travels to Earth in the form of electromagnetic waves. The signal is transmitted from the radio tower as radio waves. The radio waves, which are electromagnetic waves, travel from a radio tower to your radio. The radio waves interact with your radio antenna to produce an electrical signal. To find out what happens next, click the radio. The electrical signals are converted into vibrations in the speakers. These vibrations disturb the air around the speakers, making mechanical waves. These mechanical waves are sound waves that travel through the air to your ears. Now that you've learned about the types of waves, see if you can label their parts. Drag each word to the correct location. Great job! Transverse waves have crests and troughs, while longitudinal waves have compressions and rarefactions. Which kind of wave causes particles to vibrate parallel to the direction the wave is moving? Click your answer. That's correct. Longitudinal waves cause particles in the medium to vibrate parallel to the direction the wave is moving. How is the motion of particles in the medium different than the motion of the wave? Type your answer in the box and then click OK.
I always have to skip that one since we're unable to type.
You've learned a lot about waves. Let's take a minute to recall what we've learned. Mechanical waves are caused by vibrations. They travel through a medium. Electromagnetic waves do not need a medium. They can travel through empty space. Waves transmit energy, such as light and sound energy. Mechanical waves disturb the particles in the medium they move through. Transverse waves move the particles perpendicular to the direction of the wave, and longitudinal waves move the particles parallel to the direction of the wave. Now that you've finished this lesson, if you wish, you can go back and review any part of the lesson again.
All right, from PBS Learning Media, I'm going to show you this link here titled, What is a Wave? Actually, I'm going to show you a different video. The first one is just showing a transverse wave. This next one's a longitudinal wave. All right, so after today's lesson, I'm going to ask you to go to IXL and specifically to go to 8th grade science. You can type that in here, 8th grade science, and you can take about 15 minutes to go through some review questions. If you look at letter K, specifically has questions about waves. Make sure that you're looking at your learning plan that I emailed to your parents today, and that will show again the activities that you'll complete each day for physical science. If you have any questions, you can email me at heidi.younger@centralhealth.com. As always, I hope you have a great day, and I'll talk to you soon.